Hello everyone, welcome back to another GIS lecture video. And in this lecture video I want to continue our discussion on remote sensing by talking about this idea of interactions with matter. Okay? And so we left off last time with this idea of electromagnetic radiation and the electromagnetic spectrum, dealing with this idea that we had a wave traveling with a constant speed in a specific direction, and that we could measure or quantify or categorize, right, this radiation by this idea of wavelength, which was the distance from one peak to another peak. Okay? And so what I want to do now is I want to go through and talk about what happens after the energy's been emitted. And so we're going to walk through a nice diagram. Okay? And so as we do with most things in remote sensing, right, we're going to start off with the sun. Happy, bright, and shining. Right? And so what we learned from the previous video, right, was that the sun emits, right, different wavelengths of electromagnetic radiation in what's called a spectrum. And so we're going to focus our discussion right now on a single wavelength of red radiation, which I'm going to designate with this red line here. Right, so this, just wait here to specify. Right, this is our electromagnetic radiation, or our ER. Okay, and what I want you to imagine is that the sun emits this radiation. It's heading towards Earth. And on Earth, we have a very simple system where all we have on Earth is this basic little leaf here. Right? The principle is going to apply at scale. Right? But for now, let's just imagine we've got this nice happy leaf starting to bud. And this wavelength of red light coming from the sun encounters the leaf. Okay? So just to sort of recap what we're trying to talk about here, we're trying to talk about this idea of interaction with matter. Let's try not making that look quite so messy. Interaction with matter. Right? What actually happens when the sun emits the radiation and the radiation hits something else? Okay. Well, there are really four things that can happen, but we're going to talk about three of them. Right? So there's three things. Right? Three things can happen. Right, the first thing that can happen, right, when this energy comes through and hits the leaf, the first thing that can happen is it actually just goes straight through the leaf and moves on to hit the ground. Right, it going straight through, right, this process is called transmission. Right, so the first thing that can happen is transmission. Which is the idea that the energy passes through the object. Right, that's the first thing that can happen, is the light can simply just pass right through it. Right, a good example of this would be if you're sitting or standing, right, in a canopy of trees, where the canopy is completely blocking your ability to see the sun, and you look up, right, what you might notice is that the bottom of the canopy is a nice bright green color. Well, why is that? That's because green, or the majority of the green light that the sun is emitting, is actually just passing right through the leaf. Right? So what we see on the other side of the leaf, right, is what's being transmitted through it. Okay? The second thing that can happen, right, is it hits the leaf, and it's actually taken into the leaf and used for things, right? If the energy is taken into the object, right, we call this absorption. Let me make that a little bit cleaner, right? We call this absorption. Right? And so the second thing that can happen, right, is absorption. And with absorption, right, the energy right, is taken into the object and used for work. Right? I'm leaving work intentionally vague here because it's kind of outside of the scope of this class, but some good examples of absorption. One, think about photosynthesis, right? Hopefully we've all learned about photosynthesis, the idea that plants take in sunlight and carbon dioxide and convert it to water and air, right? The energy that light, right, that is being absorbed and it's being used, that energy is actually being used to catalyze photosynthesis, right? That's where the energy part of photosynthesis comes from. Another good example, as I mentioned in a previous video, is the idea of microwaves, right? When you use a microwave to cook food, heat water, whatever, what you're actually doing is you're bombarding the food with microwave wavelength radiation. The food is absorbing that, and it's using that energy to actually heat itself up. Okay? So we have transmission, things pass through, we have absorption, the energy is actually retained and used for something. And then finally, the third thing that can happen is that it bounces off. Right? When it bounces off, this is reflected or reflection. Right? Reflection. So the third thing that can happen is reflection. Reflection is when the energy is bounced off the object. Right, and again, right, we can see that in the diagram. Hits the leaf, bounced off the leaf. And what I'm going to do is I'm going to put a star here. Big star. Right, reflection, this is key to remote sensing. Right, because you can imagine what we actually do, right? Visually, humans, right? We have our eye, which I realize I made look really creepy here, right? But we have our eye here. And what we see, what we as humans see, is what's bounced off, right? That's why leaves look green to us, right? Because green light is being either transmitted or reflected. It's not being absorbed. right? That's why green leaves look green to us. That's why a lot of things look the color that they do, is because light is being reflected to our eye. So what we do with remote sensing is we replace the eye with a sensor, right? Whether it's in space, on an airplane, on a drone, right? Or it's a digital camera on your cell phone, right? We replace the human eye with a sensor that's capable of measuring that reflection and recording the value, which we're then able to convert into an image, right? Again, think picture, like think a cell phone picture, right? So, taking a step back to recap, we have energy being emitted from the sun, hitting an object. It either passes through it via transmission, is taken into the object to do work via absorption, or, most important to remote sensing, it bounces off the object via reflection, where it then hits the sensor. Okay? And so what I want to do is I want to do two terms, right? We have irradiance right? Irradiance is the energy reaching the object. And then we have, I'm not underlining, we have irradiance. And then we have radiance, which is the energy leaving the object. Okay, so we have irradiance, energy coming in, radiance, energy coming out. So radiance is the amount of energy that is reflected, right? And so if we do some labels here, right? If we label irradiance with an I, absorption with an A, reflection with an R, and transmission with a T, right? We can see, right, sort of making an equation from our three things that happen, right? We have the energy that's coming in, right? The energy that reaches the object, the irradiance, the energy coming in, right, has to be equal to the energy that is reflected plus the energy that is absorbed plus the energy that is transmitted, right? I like to think of this as IRAD, right? Irradiance equals reflectance plus absorption plus transmission, right? That part that is reflected, right? That is also the radiance. That is the energy that is leaving, okay? So, one other equation, right? Percent reflectance. Right? Percent reflectance is going to be R over I. Right? The amount of energy that's leaving divided by the amount that came in is going to tell us what proportion of the energy was reflected. Again, because IRAD, right? We know that the amount incoming is either reflected, absorbed, or transmitted. And so we can calculate from that, right, the proportion of energy that was reflected by dividing the reflected energy, or the radiance, by the irradiance. And this measure here, right, this is the gold standard remote sensing. right? If it's possible to accurately make this calculation, this is going to be the gold standard, right? Figuring out how much, what proportion of energy was reflected, that is the gold standard. If you can do that, that is the best possible remote sensing data you can have. Okay? So hopefully this idea of the interactions that can happen, this idea that the sun is emitting energy, which we call irradiance, it's being bounced off, which we call reflection, which we call radiance, right? The energy that is reflected we call radiance. The ratio between those is percent reflectance. So as always, if you have any questions, please reach out. Thank you.